Namaste. Welcome to Dr.ARM's chemistry. Today we will discuss the next part of this topic, coordination chemistry, and that is ligands. So in this point we will see what are the types of ligands, and before that we will see the simple difference between a complex and the double salt. So first of all, we will see what is the difference between a double salt and a complex salt. So first point, we will see what are or we will see here what is double salt and a complex salt. So first of all, we will see this point. For example, if we take KCl, MgCl2, KCl, MgCl2, or any other this type of compound in which we can find or another example, if we can also take that FeCl3 thrice KCl, FeCl3 thrice KCl, or in other words we can say KCl, AlCl3, or there are such number of examples where we find that the two or more salts. So this is a double salt, and here you find that 2, so it contains two salts. One is FeCl3, another is KCl. It means here we are observing two salts, simple salts, which are coming together and forming a homogeneous mixture, and which can be precipitated or separated in the form of a different solid of different crystal structure, different color. So if we mix these two solids in the aqueous form together, and after evaporating the solvent, if we try to crystallize out the product, we get this type of a double salt. But what is the difference between two different salts and a double salt? So these two different salts can give taste. So if we try the solution of aqueous solution of this salt, and if we analyze it according to qualitative analysis, we can detect the presence of here Fe3 plus by common tests. Similarly, we can detect the presence of this Cl minus. Means the simple salts can show in aqueous form, can show the presence of these component ions, cations and anions. Similarly, this will also show the presence of K plus and Cl minus by the suitable test. Now, if we say this salt, when this salt is also dissolved in water, it can also show the presence of Fe3 plus, K plus and Cl minus. Means this double salt shows in their aqueous state presence of all the component ions. Similarly, these salts, two different salts, independently in their aqueous solution can also show the presence of their component ions. But when the two salts are mixed, their appearance is different. Their crystal structure is different. Some composition is also different. But ultimately, the chemical nature of these individual salts and this compound salt or a double salt remains the same. So this is about double salt. Now we will see a complex salt. For example, if we take this K3 FeCl6. So here, if we dissolve this salt in water, that is aqueous solution of this complex salt, we can find the test for K+. We can detect the presence of K+ in the aqueous solution by our qualitative analysis. But here in this portion we cannot show the presence of Fe and Cn. No detection of Fe 3+ and Cl-. So here the entities or components shown in square bracket do not show the presence of Fe and Cl-. So this is different from a double salt. Why it is called complex? Because the contents or components present in shown in square bracket are not detected in water. Why it is so? Because they are strongly bound with each other by means of covalent bonds or coordinate bond. So Cl- are strongly bound with Fe3+, and that is why they are not dissociated in water. So they are not ionized and detected by our simple tests. So in this way, there is important difference between a double salt and a complex salt. Next, we will see the types of ligands. The types of ligands. So here we find that we have already seen the nature of ligand and what are the types or what is their alternative names such as Levy's acid and Levy's bases. So we have already seen what are Levy's acids and Levy's bases. So Levy's acids are metal ions and Levy's bases are called ligands. So this is the difference between the species which are present in a complex. Now we know the metal ions. Here in case of complex or coordination chemistry, the Levy's acid can be a metal ion or it can be a neutral metal atom means with zero oxidation state. So this is we have already seen in acids and bases. Now we will see what about this Levy's bases, which are also called ligands. Now we will see, or we know that these metal ions in a complex are bonded with ligands and by means of a lone pair which is shared by this ligand with metal ion. So metal ion is sharing its electron pair with ligand is sharing its electron pair with metal ion. So this electron pair is moving towards metal ion. Electron pair of this ligand is moving towards metal ion. So it has directional characters. It is covalent bond, but simultaneously it has directional characters. Therefore, it is called a coordinate bond, or it is also called a dative bond. It has directional characters, and that is why it is called a dative bond. So this structure or bonding is observed in complexes, and here we are now going to see what is the nature of these ligands and types of these ligands. So as we have already seen that the ligands have different types, and we can classify the ligands on the basis of various parameters. So what are these parameters? First of all, we can classify the ligands on the basis of their point of attachments or number of electron pairs that the ligand can share with the metal ion. So first type is on the basis of number of electron pairs shared, or in other words we can say point of attachments, points of attachments. There are some ligands which are having or which are carrying only one electron pair, and with this one electron pair the ligand can form coordinate or covalent bond with the metal ion or metal atom, and such ligands are called monodentate ligands. So first is monodentate ligands. So they have only one point of attachment, means only one donor atom carrying only one electron pair. So here we can take the example of say Cl minus, Br minus, I minus, F minus, or we can have this H2O or NH3 or pyridine, or there are such number of examples such as R, alkyl group or aryl group, R, NH2, etc. So there are several such examples which we can show on this monodentate type of ligands. So they, because of this only one electron pair, their point of attachment is only one, means this ligand can form bonding with the metal ion at only one point. So for example, you can take cobalt and it is say like this. So say it is octahedral. So Cl can form such a single bond. Similarly, NH3 can form such a single bond. So it is a, or we can show here it is a pyridine, or anyway in this way. So here the structure is like this, but here the point of attachment or donor atom is nitrogen. It has one lone pair. Similarly, this nitrogen has also one lone pair. So the donor atom here is nitrogen, or if it is water, or if it is OH minus, the donor atom is oxygen. So in this way we can have the other ligands such as RSH, where thiol group is there, and or we can also simply take the SH, or there are several other ligands. So this is about the first A type, that is monodentate ligands. Second is polydentate. Polydentate means it has two or more points of attachments. It has two or more points of attachments. Two or more points of attachments means in such case there are two or more donor atoms which can provide two or more electron pairs with which it can establish covalent bonding with the metal ion. Now if you see the examples of this type, then we will come to understand how is this polydentate ligand works. For example, if we take this a metal ion. Now if we see the example like this, that is NH2, CH2, CH2, then NH2, then this can form a covalent bond like this with metal ion. So here the example is ethylene diamine. So this example is called ethylene diamine. So it has two donor atoms. These are donor atoms. So therefore it is called a bidentate ligand. So this is called a bidentate ligand. So similarly, there are other such bidentate ligands. For example, so this is oxalate. So it is obtained from oxalate or oxalic acid. Oxalic acid, it is called oxalate. Oxalate ligand. Similarly, there are many such ligands where we can have the nitrogen as a donor atom, oxygen as a donor atom, means the points of attachments may be of the same type or different type. For example, dipyridine, where we can have two pyridine molecules in which the donor atoms are only two nitrogens. Here you can find that there are both donor atoms of the same element, that is oxygen. So there is no such distinguish or classification on the basis of different types of donor atoms of the same molecule. When molecule is same, we cannot, there is no need to distinguish between them. Or other words, we can say the molecules such as NH2, CHR and COOH. This is amino acids. So here you can have the donor atoms like this, nitrogen and this oxygen. R is alkyl or aryl group, or it can be H. So it can be H, alkyl group or aryl group. So depending upon this R, the amino acid is different, and this is also a bidentate ligand. So there are several types of such bidentate ligands which can we use for different purposes. Now, in this polydentate ligand, we can have another example, say tridentate ligands, where we can have three ligands with 3 points of attachments. For example, NH2, CH2, CH2, NH, CH2, CH2, NH2. So here you will find that this is a donor atom, this is a donor atom, this is a donor atom, and these are the electron pairs with which this ligand can form coordinate bond with metal ion. So therefore, there are 3 such points of attachments, and therefore it is called a tridentate ligand. So there are many other such ligands which are similarly tridentate, tetradentate, pentadentate, hexadentate, etc. Now if we take the example of hexadentate ligand, that is EDTA, ethylene diamine tetraacetic acid, so where we can have the structure like this. So these are the points of attachments. So you will find there are 6 such points of attachments, and therefore it is called hexadentate ligand. So in this way, depending upon the number of points of attachments, the ligands can be classified into the monodentate and polydentate types. Then next is ambidentate ligand. Ambidentate ligands. Ambidentate means there is at a time only one point of attachment, but there are the species or ion contains different atoms of different elements which can provide the electron pair or which can act as a donor atom, but only at one instant it can use only one point of attachment. But there is possibility of use of different atoms which can donate the electron pair. So such ligand is called ambidentate ligand. For example, SCN. Here we can have this nitrogen as a donor atom, and alternatively we can have CNS. Here sulfur is a donor atom. Means species is same, thiocyanate, but the points of attachment is different. So because of this, they are called ambidentate ligands. And when there is such type of point of attachments, we have to indicate when the ligand is forming covalent coordinate bond with metal ion, and while naming the species we have to point out which is the point of attachment. And another example we can show of this ambidentate ligand is NO2 minus. here we can have the oxygen as a point of attachment. Out of 2, only 1 nitrogen has a point of attachment. So this is a point of attachment. And in another way, nitrogen itself is a point of attachment. So here we can have such different point of attachment depending upon that. So this is ambidentate, means nitrogen or oxygen can behave as a point of attachment. So it is called the ambidentate ligand. Then we can classify the ligands on the basis of donor atoms. Third, on the basis of donor atoms or atom. For example, we can show these donor atoms like this: carbon, nitrogen, oxygen, sulfur, phosphorus. So in this way we can have the different points of attachments. For example, if we have this carbon, we can have this carbonyl, carbon monoxide as a molecule. Then there are some other examples in which we can find this type of carbon, R and C. Similar here, C is the point of attachment. C is the donor atom. Then again, if we see this nitrogen, we can have this NH3, R, NH2, or here we can have the organic species like pyridine, or nitrogen containing any other species like this. Similarly, if we take this, so here the point of attachment is nitrogen. Here also the point of attachment is nitrogen. Then if we take the ligands with oxygen as a donor atom, then we can have this H2O, OH minus, or the oxo, O2, peroxo, where it is, or we can have any other examples in which we can have this oxygen as a donor atom, or sulfates, carbonates, etc. SO4 2 minus, CO3 2 minus, etc. So there are such number of examples. Then if we take the donor atom as a sulfur, then it is SH minus, R2S, R2 ether, or any other sulfur containing species, as we have seen earlier, SCN or CNS as a donor atom. Then here we can have PX3, R3P. So these are some examples with which we can say that the ligands can be classified on the basis of the donor atom. So all these are showing, these are the donor atoms on the base, and these are the examples. So we will stop our discussion here, and in the next lecture we will see what is the nomenclature of these ligands or complexes. Means both the ligands as well as complexes, they are named on the basis of a set of certain rules. So till then, goodbye, see you next time. So please subscribe to this channel and press bell icon and like button. So thank you very much for watching.